Assalamu alaikum. In the name of Allah, who is the most beneficent and most merciful. Today, my topic of presentation is sulfuric acid. First, let me introduce myself. My name is Arid Fatma from Department of BS Chemistry. My ID is 001 and this is the presentation of industrial chemistry which is submitted to Sir Hizer. Here, some of its contents. First, we talk about its introduction, second, its structure, then, what are its physical properties and its manufacturing process. So, what is its introduction? Sulfuric acid, also known as Isle of Vitriol, is a mineral acid which is composed of elements sulfur, oxygen, and hydrogen. And it has a molecular formula of H2SO4. It is a colorless, odorless, and viscous liquid that is soluble in water and is synthesized in reactions which are highly exothermic. Then it is the structure of sulfuric acid. Its geometry is tetrahedral and the angle is 109.5. So, what are its physical properties? Sulfuric acid is a clear, colorless, oily liquid and it is highly corrosive. It is the dehydrating agent and its melting point is 10.35 degrees Celsius. Sulfuric acid has a boiling point of 315 to 338 degrees Celsius. Its vapor density is 3.4 and specific gravity is 1.84. So here we talk about manufacturing process of sulfuric acid. There are two types of manufacturing process of sulfuric acid. First is contact process, second is lead chamber process. So first we talk about contact process. The contact process is the current method of producing sulfuric acid in high concentrations which is needed for industrial process. Platinum was initially used as a catalyst for this reaction. However, as it is susceptible to reacting with arsenic impurities in sulfuric feedstock, vanadium in the form of 5 oxidation state oxide is now preferred. So, what is the catalyst which is used in the process of contact process? The catalyst used in the contact process is vanadium pentoxide. The action of the catalyst is not to yield more product, but to make the reaction faster by forcing the reaction to reach at equilibrium quickly. So these are the steps which we follow in contact process, which is total 4. These includes first extraction of sulfur, second preparation of sulfur dioxide, the third is conversion of sulfur dioxide to sulfur trioxide, and the fourth step is conversion of sulfur trioxide to sulfuric acid. So here is the first step, which is extraction of sulfur. Pure sulfur is required for production of sulfur dioxide gas. So there are many sources for extracting sulfur. The most important one, these are the recovery from natural gas and oil. The organic or mineral parts of these are removed to obtain sulfur. But apart from the extraction of pure sulfur, there are few ways by which sulfur dioxide can be extracted. Metal refining is one of them. Many metal ores occur as sulfides in soil, but later they are roasted to obtain their respective oxide and sulfur dioxide. So consider the extraction process of lead. When we extract lead, then it produces the lead oxide and sulfur dioxide. Likewise, sulfur dioxide can be obtained from metallurgy of copper, nickel, zinc, and so on. In China, most of the sulfur dioxide is extracted from pyrite, which is an iron ore, an iron sulfide ore. The second step is preparation of sulfur dioxide. Sulfur dioxide can be prepared by burning pure sulfur in presence of excess air. This causes the formation of dioxide of sulfur. The process of sulfur dioxide preparation is as follows. The first step is molten sulfur is pumped into the stationary atomizer. This causes the formation of atomized sulfur. This atomized sulfur is applied to hot furnace and air is preheated and dried using a sulfuric acid dehydrator and is also applied to hot furnace. The air and atomized molten sulfur are kept at one end of the hot furnace. When a reaction occurs, sulfur dioxide is produced at the other end. So sulfur dioxide is also produced by roasting sulfidic ores, pyrites, which are the iron sulfide, or for example, converted into sulfur dioxide and iron trioxide calcine. This reaction is currently preferable carried out in multiple hearth roasters, rotary tube furnaces, or fluidized bed furnaces. So we talk about how reaction carried out in multiple hearth roasters. In multiple hearth roasters, which have up to 14 hearths, the pulverized material is agitated with stirrer arm and is transported from one hearth to another. So thereby continuously renewing the surface of the ore being calcined. The roasting gases leave the furnace with 9 to 12% by volume of sulfur dioxide, which is at the temperature of 700 to 750 degrees Celsius. They are cooled over a waste heat boiler in which steam is produced. So next we talk about how the contact reaction is carried out in rotary tube furnaces. In rotary tube furnaces, pyrites and air are intimately mixed in countercurrent. The reaction products are cooled by built-in tubes in which water is evaporated, thereby removing the heat of reaction as unusable heat. So, how reaction is carried out in fluidized bed furnaces? In fluidized bed furnaces, consisting of a cylindrical roasting shaft which extends upwards conically to a settling chamber, the sulfiding material is roasted at 650 to 900 degrees Celsius temperature. The air enters via grill and is uniformly distributed in the shaft, and a fluidized layer is produced mainly consisting of iron trioxide, which is called calcine. The hot gases, which is containing up to 14% of sulfur dioxide and a little sulfur trioxide, which are cooled in a waste heat boiler. So, sulfur dioxide can also be obtained from waste sulfuric acid by cracking. Impure sulfuric acid occurs in many processes, particularly in organic chemistry, petrochemical industry, and the metal industry. The safest way of avoiding waste problems and possible environmental burdens is thermal cracking with the formation of sulfur dioxide. So the third step is conversion of sulfur dioxide to sulfur trioxide. The purification of air and sulfur dioxide is necessary to avoid catalyst poisoning, uh, for example, removing catalytic activities. The gas is then washed with water and dried with sulfuric acid. To conserve energy, the mixture is heated by exhaust gases from catalytic converter by heat exchangers. Sulfur dioxide and dioxygen react and form the sulfur trioxide, and the heat is minus 197 kilojoule per mole, which is used in this reaction and released. So so the fourth step is conversion of sulfur trioxide to sulfuric acid. So hot sulfuric acid trioxide passes through the heat exchanger and is dissolved in concentrated H2SO4 in the absorption tower to form oleum. Of sulfuric acid and sulfur trioxide, and the sulfuric acid is in the form of concentrated. When reacts with sulfur trioxide, it forms the oleum. So note that directly dissolving sulfur trioxide in water is impractical due to highly exothermic nature of reaction. The acidic vapor or mists are formed instead of a liquid. So oleum is reacted with water to form concentrated H2SO4. When oleum react with water and form the then it forms the concentrated H2SO4. So the summary of the contact process is that the contact process is a present method of producing concentrated sulfuric acid which is required for industrial use. The catalyst used during the process is vanadium oxide. The contact process is divided into three stages. The stage one is sulfur dioxide preparation and purification. The second stage is conversion of sulfur dioxide to sulfur trioxide by catalytic oxidation. So the third stage is sulfur trioxide is converted into sulfuric acid. Here is the cycle of contact process. First, in the first step, sulfur react with O2 and yield sulfur dioxide, and in the second step sulfur dioxide purified. Then in the third step sulfur dioxide react with oxygen in the presence of vanadium oxide catalyst and forms sulfur trioxide. Then sulfur trioxide and sulfuric acid react with each other and forms oleum. Then oleum react with water and forms the end product which is sulfuric acid. So the second process is lead chamber process. The lead chamber process was an industrial method which is used to produce sulfuric acid in large quantities. It has been largely supplanted by the contact process. So sulfur dioxide is introduced with steam and nitrogen dioxide into large chambers lined with sheet lead where the gases are spread down with water and chamber acid. And here 62 to 70% sulfuric acid formed. The sulfur dioxide and nitrogen dioxide dissolve, and over a period of approximately 30 minutes, the sulfur dioxide is oxidized to sulfuric acid. So, the presence of nitrogen dioxide is necessary for reaction to proceed at reasonable rate. The process is highly exothermic, and a major consideration of design of chambers was to provide a way to dissipate the heat which is formed in the reactions. So here is the process of lead chamber process. The sulfur dioxide from process are was provided by burning elemental sulfur or by roasting of sulfur containing metal ores in a stream of air in a furnace. During the early period of manufacture, nitrogen oxides were produced by decomposition of niter at high temperature in the presence of acid. But this process was gradually supplanted by the air oxidation of ammonia to nitric oxide in the presence of catalyst. The recovery and reuse of oxides of nitrogen was an important economic consideration in operation of chamber process plant. So in reaction chambers, nitric oxide react with oxygen to produce nitrogen dioxide. Here, liquid from the bottom of the chambers is diluted and pumped to top of chamber and sprayed downward in a fine mist. Sulfur dioxide and nitrogen dioxide are absorbed in the liquid and react to form sulfuric acid and nitric oxide. The liberated nitric oxide is sparingly soluble in water, but it returns to the gas in chamber where it reacts with oxygen in the presence of air to reform nitrogen dioxide. Some percentage of nitrogen oxides is sequestered in reaction liquor as nitrosyl sulfuric acid and as nitric acid. So the fresh nitric oxide must be added as the process proceeds. Later versions of chamber plants included a high temperature Glover tower to recover the nitrogen oxides from chamber liquor, while the concentrating chamber acid to as much as 78% sulfuric acid. The exhaust gases from chambers are scrubbed by passing them into a tower through which some of the Glover acid flows over broken tile. Nitrogen oxides are absorbed to form nitrosyl sulfuric acid, which is then returned to Glover tower to reclaim the oxides of nitrogen. So the sulfuric acid produced in the reaction chamber is limited to about 35% concentration. At higher concentrations, nitrosyl sulfuric acid precipitates upon the lead walls in the form of chamber crystals and is no longer able to catalyze the oxidation reactions. Here are the reactions which occurs in the lead chamber process. So the first is sulfur dioxide is generated by burning elemental sulfur or by roasting pyrite ore in a current of air. So in the first reaction, sulfur reacts with oxygen and forms sulfur dioxide. But when the pyrite ore reacts with oxygen, it forms the iron oxides and plus sulfur dioxide. But the nitrogen oxides are produced by decomposition of niter in the presence of sulfuric acid or by hydrolysis of nitrosyl sulfuric acid. When niter reacts with sulfuric acid, it forms the nitrosyl sulfuric acid and, nitrous oxide plus nitrogen dioxide and oxygen plus water. So when nitrosyl sulfuric acid react with water, it forms the sulfuric acid, nitrogen monoxide, and some amount of nitrous oxide. In the reaction chambers, sulfur dioxide and nitrogen oxide dioxide dissolve in reaction liquor. Nitrogen dioxide in the first reaction, the nitrogen dioxide is hydrated to produce nitrous acid and nitric acid. But when uh, nitrous oxide react with nitrosyl sulfuric acid, it forms the sulfuric acid and nitrogen dioxide and nitrous oxide. But when nitrous oxide react with sulfur dioxide, then it also produces sulfuric acid and nitrous oxide. Nitric oxide escapes from the reaction liquor and is subsequently reoxidized by molecular oxygen to, to nitrogen dioxide. This is the overall rate determining step in the lead chamber process. And this nitrous oxide react with dioxygen and forms the nitrogen dioxide. And nitrogen oxides are absorbed and regenerated in the process and thus serve as a catalyst for overall reaction. Nitrogen dioxide react with water and oxygen and forms the sulfuric acid, which is the end product of the lead chamber process. That's all from my side. Thank you.